Hi guys, in this video we are going to be looking at the topic safety with electricity by looking at what is an overload and the different safety devices. Just a disclaimer, this topic involves mention of resistors, series and parallel circuits as well as current. So if you are not too sure on what those mean, please refer to your notes and come back to the video so that you can understand what is going on. So firstly, what is an overload? When more resistors are connected in parallel, the total resistance is lower and the current is stronger, which means that there is more current being drawn from the source. If many electrical appliances are connected to an extension socket or light bulbs in a parallel network are switched on, the total resistance lowers and the current strength increases. An overload may occur on the main circuit if too many resistors are connected in parallel. And for safety, the main circuit includes a fuse or circuit breaker that will interrupt the circuit when it reaches a specific strength. So the first safety device we are going to be looking at is a fuse. So a fuse is a safety device that is a very thin, short piece of wire with a low melting point. A low melting point means that it doesn't require much heat in order to melt it. It is connected in series to allow the current to flow through it. But how does a fuse work? If the current is too strong, the wire will get hot and melt. Remember, it has a low melting point, so it would not require much heat or current to melt it. This causes an interruption in the circuit, which stops the flow of current. A fuse must be replaced once it has melted. Wiring in older houses often have fuses as a safety device. The next type of safety device that we're going to be looking at is a circuit breaker. And a circuit breaker is a magnetic switch that automatically switches off if an overload or short circuit occurs. It consists of a coil around a soft iron core, and an electromagnet is formed the moment a current flows through the coil. So, the strength of the magnet increases along with the strength of the current. So, if the current increases, like leading to an overload, then the strength of the magnet will also increase. And this will move the two contact points in the circuit away from each other. Remember how magnets work. So this interrupts the circuit once the current reaches a certain strength. Circuit breakers are often connected to individual switches that control the stove, lights, and plugs. The switch can be switched on once the problem has been solved, unlike fuses where if a fuse has now melted, you would have to constantly be replacing it. So a circuit breaker is much better because you can just switch it on once the problem has been resolved. Earth leakage circuit breakers. This one protects us humans against electric shock. If the current that enters an appliance is different to the current that leaves, then there's a current flowing along a wrong path. So how does the earth leakage current breaker work? An earth leakage current breaker is then activated so that the electricity supply to the circuits in the house is interrupted. This can prevent fatal electric shock or cause serious burn wounds. Next, we have 3-pin plugs, and appliances normally have a 3-pin plug for our safety. So in case you're wondering why some appliances have a 2-pin plug, 3-pin plug, the 3-pin plug is mostly for our safety, and we'll see why. If you were to open up a 3-pin plug, you will see a live wire, which is brown, a neutral wire, which is blue, and an earth wire, which is green and yellow. Okay? And then the earth wire is connected to the metal casing of the appliance and is connected to an earth cable in the ground via the wall plug. So that is a way that the 3-pin plugs can protect us from electric shocks. So I hope this video was helpful to the person that requested this video. I hope that I was able to answer your question. Bye!